Alright, so good morning everyone. We will start with our lab exercise 2. We have already started this in week 6, but few of the activities were still left. So we will continue with those activities, and there is one more lab exercise for this week. Alright, so regarding this lab exercise 2, activity 1, activity 2 and activity 3, we have already finished in our class. In this we captured the Ethernet traffic, we pinged the default gateway address, and we observed the ICMP packets. So I will start with activity 4. Before starting with activity 4, let me just tell you what is an inbound traffic and what is the outbound traffic. Now inbound traffic is the traffic that moves between there is a direction of the traffic that moves between the networks. So inbound traffic means the information or the packets that are coming to our network from the internet, and outbound traffic is the traffic that leaves our network and goes towards the internet. So inbound traffic will always enter to our network or our computer, and outbound is the traffic that leaves from our computer to the internet. That means the information or the packets that we are sending to the internet. Alright, so now activity 4, activity 5. Alright, activity 4 and activity 5 and activity 6, they are related. So in activity 4, what we are doing, we will ping the default gateway address, and what we are doing, we are analyzing the local IPv4 traffic. That means the local traffic within our network. We will analyze both outbound traffic and inbound traffic. So outbound traffic is the messages that leave from our system to the other computer, and inbound traffic is the messages that our system receives. So let's start this activity. Alright, so what we have to do over here, let me just explain you the activity. We will start with the Wireshark, and then we will ping the default gateway address, and then we will stop the Wireshark capture, right? So I have started over here with the Wireshark. Alright, now over here you have to check your interface. I am connected to the Wi-Fi adapter of my house. If you are connected to the local area connection, you have the Ethernet connection, then you will select local area network, else Wi-Fi. You may have many other types of network showing in this interface list, like Bluetooth network connection, VMware network adapter. We are not concerned with this. We are only concerned with either Wi-Fi or the local area network. So what I will do, I will first of all select this Wi-Fi, and then I will click on start. Alright, now the traffic will start, it will start capturing the traffic. So what I will do, I will go to the command prompt, ping the default gateway address, and stop the Wireshark capture. So from here, let me go to the command prompt, cmd, right? Then let me check what is my default gateway address, ipconfig. Okay, so there are many adapters. So what will I do? Since I am on my wireless LAN adapter, see here, there is wireless LAN adapter Wi-Fi. So I will ping the default gateway address, which is 192.168.101, which is for me. This way you have to check that you are pinging the correct default gateway address, because same way, if you see over here, I have wireless LAN adapter for local area connection, I have Ethernet adapter for Ethernet. I'm not concerned with this because I am capturing the traffic on my wireless LAN. Alright, so what I will do now, I will ping the default gateway address, which is 192.168.101. Alright, so let me just ping 192.168.100.1. Alright, so ping is successful. After it is done, I will go back to the Wireshark. I will stop the capture. Alright, so now let's go back to the our lab sheet. Now what we have to do, we have to check the local IPv4 inbound and outbound. ping command, as I already explained you in the class, that ping command, the protocol associated with the ping command is ICMP. So we are interested only in observing the ICMP traffic. So instead of just going through the list of all these packets, what I will do, in the filter box, I will type over here ICMP. Alright, now if you see, I have ICMP, how many? 8 packets, 1, 2, 3, 4, 5, 6, 7, 8. 4 request and 4 reply. Why 4 request, 4 reply? If I go back, I have received 4 times the reply from my default gateway. So 4 times request packet has been sent from my system and 4 replies. That's why total 8 packets. Alright, so what we are supposed to do? Alright, we will observe first request packet, and then we will check the various things. Alright, this is the first request packet. I can open it like this. Alright, so let's go back here, what I have to do. Alright, so let's expand point number 4. Let's expand Ethernet 2. Alright, so going to Ethernet, here. Okay, so Ethernet, which is the data link layer. Alright, now source system. The source shows the MAC address of the source and MAC address of the destination. Now source MAC address is the MAC address for my system. Fine, so how can I verify this is for my system? Let me go to the command prompt. What will I type here? ipconfig/all. Alright, so when I go here, wireless LAN adapter Wi-Fi, right? So let's check the okay, let me just type here no need for ipconfig. I can check with the getMAC also. Alright, so if you see over here, getMAC. Now the physical address for my system is AC B570147901. Alright, so rest all is media disconnected. I am not concerned with this. I can use the getMAC also. So if you go over here, if you see over here destination, and now the destination field will contain the MAC address of your default gateway, and the source MAC address will belong to your system. So this way I have selected let me just go to Wireshark. Okay, so AC B570147901, which is the MAC address for my system. Alright, now the destination is for the default gateway. Alright, destination MAC address. Now ipconfig all, or I can use getMAC to confirm it. Again, I can use the getMAC also. Okay, let me go over here. Alright, so 08 is not showing over here. Let me just check another command, arp-a. Yeah, arp-a, you can use it. You can use the command arp-a to check the physical address of your default gateway. So if you see over here, I pinged the IP address. Okay, let me just go back what I pinged. Okay, wait. Yeah, I can even see from here I pinged 100.1, right? So if you see over here, there are many default gateways. So this one I pinged, and the physical address for this default gateway is 08480A C5E3CC, which matches over here. So in the Ethernet field, the source MAC address will be the MAC address for your system, and the destination MAC address will be the MAC address for your default gateway, which you have IP ping. Now coming to the next field, which is type. Type shows the protocol used by the next higher layer, and the next higher layer after the data link layer is the network layer, and the protocol used is IP, and the code is 0800, and this field takes 2 bytes. Alright, now what is the next? So coming to point number 8. So we will expand now IP protocol, which will tell us the IP address. Alright, so here is the IP address. If you see over here, this is the source address, right? Source address is the address for my system, IP address for my system. How can I verify? I can use ipconfig or ipconfig on any one command I can use. So if you see over here, when I go and search IPv4 address, this is the IPv4 address for my system, 192.168.108, and default gateway is 192.168.101. And next is the version. So the destination IP address will be the IP address for my default gateway, which I have pinged. Alright, after this is the header length. Header length for the IP is always fixed, which takes 20 bytes. Total length of this packet is 60 bytes, right? So how much will be the payload? Payload means how much data this internet IP packet is carrying. So total length minus the header length will give me the payload field or the data field. So total length is 60, header length is 20 bytes. So the length of the data, or I say length of the payload, is 60 minus 20 bytes, which is the 40 bytes. Alright, coming to next, fragment. In the class we discussed about fragment offset. Sometimes IP is fragmented. If IP datagram is quite bigger, routers may break that IP datagram into the fragment. So if you see over here, fragment offset is 0. When fragment offset is 0, that means that IP datagram has not been broken into further packets. It has not been fragmented. Alright. Next is TTL field 128. Protocol. Protocol is the ICMP. ICMP stands for Internet Control Messaging Protocol. Last we go to the ICMP field. Now ICMP type is 8 because it's a request packet, and code is 0. So type is 8 for request and code is 0, and this is the data field, right? So this was outbound traffic. That means the request packet is outbound traffic because the packet is leaving off from our system and going to the other network. Alright, local IPv4 inbound traffic. That means now we will observe the reply packet from our default gateway. So whatever the Ethernet addresses or the IP addresses were there in the request packet, now it will all be reversed. So let's see over here. I will close it now, and in the Wireshark I will click on the ICMP reply packets. It's second packet. You can see here also it's a reply packet. Alright, let me just first of all, okay, let's go here. Alright, so what are we going to do? We are going to observe the same fields here. Alright, first of all, let's observe the Ethernet field. Now in the Ethernet field, the destination, the source MAC address will be the MAC address for the default gateway, and the destination MAC address is the MAC address for my system. Type as usual is IP. Okay, coming to the network layer, source IP address is the IP address for the default gateway, and the destination IP address is the IP address for my system. Rest all things remains the same. Fragment offset is 0. Protocol is ICMP. Now coming to the ICMP type is 0, code is 0. So in case of ICMP reply packet, type is 0, but in ICMP request packet, type is 8. Code is 0 in both the cases. So that was about the this was local IP v4 traffic. Now this was, we captured local IP v4 traffic, inbound and outbound. Now let's capture remote IP v4 traffic. Local means that the server that I pinged was lying in my network. Remote means the server that I will be pinging now will not lie in my network, it will be located somewhere else. So what I will do in activity 7, 8 and 9. In activity 7, 8 and 9, I will be capturing same thing, IPv4 traffic, but now it will be remote. Remote means the server that I will ping, it will not lie in my network, rather the server will be somewhere else, maybe in USA or somewhere else. So what are we going to do in this activity? We will start with the Wireshark capture and then we will ping 8888. As I told you in the class also, the 8888 IP address is one of the Google DNS server, the free server, which can be used by the network administrator to troubleshoot for the network connectivity. So let's start doing this activity. I will close this. I will close the previous Wireshark capture. Alright, I don't want to save it. Alright, so let's check the activity again. 7, 8 and 9. Now we will be doing it. Alright, activity 7, we will start with the Wireshark and then we will ping, use the command ping 8888 and then stop the Wireshark capture. So again we will be observing the ICMP packet, because ping command, the protocol associated with the ping command is the ICMP. Alright, let's start. So what I will do, I will first of all start with the Wireshark capture. Let me just clear the filter box also. Alright, so let's start it. Next I will go to CMD and then what I will do, ping 8888. This is the remote Google DNS server which is not in my network. So ping is successful. Now what will I do? I will come back to the Wireshark and stop the capture. Alright, so going back here, okay, so the activity is done. Now what we are going to do? We are going to do the same. We will analyze the remote IPv4 outbound traffic and remote IPv4 inbound traffic. But in this case, we will not be able to check the destination MAC address. Alright, the destination MAC address, I will explain you which device will have the destination MAC address. Alright, so let's go over here. Let's use the filter box, type here ICMP. Alright, so again the 8 packets, if you see in the destination it's 8888 and in the source address it's my system address. Alright, so let's quickly observe the first request packet. Here is the first request packet. Right. Alright, so let's start with the data link layer, which is the Ethernet layer. Source IP address AC B578147901 belongs to my system. Alright, let me verify it. I can use get MAC. Alright, so AC B570147901, it belongs. You can use ipconfig or ipconfig also. So, but I find get MAC is quite easier because it gives you fewer results without any confusion. Alright, now coming to the destination MAC address. Here I am talking about MAC address. Now always remember that we don't see MAC address for any of the server. We can only check the IP addresses of the server. So the destination MAC address here belongs to my default gateway. It does not belong to the server 8888, which is the Google DNS server. It belongs to my default gateway. Okay, let's check it. So the command is ARP dash A. Alright, if you see over here, now here you have to check, you have to find out is there any matching physical address. If there is matching physical address, you will definitely find it. Okay, so 084F0AC5E3CC. so this is the MAC address for my default gateway. It is not the MAC address for the Google DNS server. Remember, I pinged over here Google DNS server. We will never see the MAC addresses for any remote machines. We can only see the MAC address for our default gateway, but we can always check or look up the IP addresses for the remote machines. This was the important point to note over here. Alright, if you see over here in point number 5, it's written, notice that remote internet layer traffic is processed at local link layer traffic. So the default gateway will route the packet to the internet. So the MAC address is for your default gateway, not the MAC address for the Google DNS server. Alright, so observe the type field. Type field will have the same value, 0800. Alright, coming to the internet layer, network layer. Now, source IP address 192.168.108 belongs to my system. Destination IP address belongs to the server that I pinged. I pinged 8888. So, it belongs to the server that I pinged. Version is 4. Header is 20 bytes. Total length is 60 bytes. Fragment offset is 0. Time to live is 128. Protocol is ICMP. Alright. When I go to ICMP, type is 8 and code is 0 as usual. Alright, now coming to let's observe the next inbound traffic. So this was the outbound traffic, which was the request packet. Now we will observe the reply packet, which is the inbound traffic. Alright, so all the fields will be opposite of the request packet. Alright, let me go here. Let's check reply packet. Alright, so reply packet. I will start with Ethernet to source MAC address is the MAC address for my default gateway, not for the 8888 Google DNS server. Destination MAC address is the MAC address for my system, my computer. Alright, internet, coming to the network layer, source IP address is the IP address of the server which I pinged 8888, and destination IP address is the IP address for my system. Version rest, all the fields are same. Coming to ICMP, type is 0 and code is 0. So that was all about activities 7, 8 and 9. Alright. Now 10, 11 and 12, they are also the same activities. You may try to do it by yourself at your homes, and if you have any concern, I will open a discussion board on Sunday during your class time, so you can raise your concern. So activity 10, 11 and 12. I am not doing it now. You are supposed to try it by yourself, and for any concerns, any questions, just write in the discussion board. Alright, now we have the last activity in this, which is activity 13, 14 and 15. Here what we are going to do, we are going to capture the HTTP packets, Hypertext Transfer Protocol, right? So HTTP, that means we are going to browse the internet. Alright, so let me just close it. I will close the command window also. Alright, I will close this Wireshark also. Let me first of all explain you the activity, what we have to do in this activity. Please try to do activity 10, 11 and 12 by yourself, and please raise your questions and your concerns. Okay, coming to activity number 13, what we are going to do here, we are going to start a Wireshark capture Alright, then we are going to browse the internet and open any web page, and we will wait until that web page is fully opened. All the objects on that web page, they are fully downloaded. Then what we will do, we will stop the Wireshark capture and then we will observe the HTTP packets. Alright, so in this case I am going to browse Cambridge University website. So what will I do? I will start with the Wi-Fi. You can browse any other website also. I will clear this from here. Alright, it's taking time. Okay, so Cambridge University website is www.cam.ac.uk. You can browse UCJ also, whatever you want. You can try with that. Alright, so the page is fully opened. Now what will I do? I will go back to the Wireshark. I will stop it. Right? Now we are concerned only with the HTTP packets. So going to the HTTP packets, I will go to the filter box, type here HTTP. Alright, press enter. Okay, I think HTTP packets are not captured right now. So what I will do, I will discard this capture. I will do the activity again. Alright, so if you see that HTTP packets or sometimes there is an error in the activity, repeat that activity. So I will start this activity again because there was an error. So let me start it. Okay, alright, it's capturing. Let's check. www.cam.ac.uk. cam.ac.uk. Alright, so the page has been fully opened. Still it's not capturing. It's capturing only SSDP. I think it has gone slow. Alright, let me try to do it once more. Okay, because here the protocol I should see should be HTTP. No, I don't want this. Alright, let me stop it. Okay, let me just close it. Let me restart the Wireshark again also. Okay, let me start the Wireshark. Here is the Wireshark. Alright, so it's just going to start. Alright, so here is the Wi-Fi. I will choose this interface Wi-Fi. I will start capturing. I think now it's okay. Alright, what will I do? www.cam.ac.uk. .uk. Alright, I think the page has been fully opened. Okay, let me just check. HTTP, I have not yet stopped the capture. It's not capturing. Okay, let me try to browse any other website. Okay, www.ucj.edu.sa. Okay, so this page has also been fully opened. Yeah, now I have captured. If you see over here, HTTP has been captured. Okay, so let's stop over here. Clear? Now if you see over here, I have browsed two websites. Fine. So first of all, let me go over here. I will like to see only HTTP packets. I type here HTTP, press enter, so that I get only, I am concerned with HTTP packets. Now if you see, I have opened two websites, University of Cambridge and University of Jubail University College. Now, which HTTP packet related to which website I should browse? If I want to look up, if you see over here, I get the destination IP address. Now let's look up what is the IP address for the University of Cambridge and what's the IP address for the Jubail University College, so that we can check only those packets. So if you remember, I will go to CMD. If you remember, I explained you command nslookup. Nslookup is a command by which you can check the IP address of any server. Nslookup www.cam.ac.uk. I am doing this to check the IP address of Cambridge University. So it's 128.232.132.0. Alright. So let me just check. I have captured packets between this 128. No, I don't have any packets, if you see over here. Alright. Let's check what is the IP address of the UCJ nslookup. Okay, www.ucj.edu.sa. right? So it's 212.102.11.2. If you see here, 212.102.11.2. The packets between UCJ and my system have been captured. So I will not analyze the HTTP packet of the Cambridge University. Rather, I will analyze only the HTTP packets of the Jubail University College. You can try because it was opening before. I don't know why it is not capturing now. You can try with other websites also. So why I did this step in the command window, just to check the IP address of a destination machine, the website which I browsed, so that I can analyze only those packets only. Alright. Okay. So going back here, HTTP has two types of packets, HTTP GET and HTTP response. Normally it is GET. If you see GET, it's a message from, it's a HTTP GET means it's a HTTP request packet. HTTP 1.1 means it's a HTTP reply or response packet. So HTTP GET means it's a request sent from my system to the UCJ server to open that page, and HTTP response or reply packet means my system has received a response from the JUC server. Alright, so going back here, so we have filtered the packets to show only HTTP packets. I will click one of the packets, and what will I do? I will check port number, physical address, IP address, and the host name. So these are the four things we are going to check. Alright, so let's check. We are going to check both the packets. I will check HTTP GET and HTTP reply. So this is the first HTTP GET packet. Alright. So what are we supposed to check? We are supposed to check four things. First thing is the physical address, IP address, port number, and host name. Alright. So physical address. Alright. Now source physical address is the physical address of my system. Destination physical address, MAC address, is the address of my default gateway, not the MAC address of the Jubail University College website, because we never see the physical addresses of any server. Type field is the same, IP. Alright, coming to the network layer, version 4. Now source IP address is the IP address of my system. You can verify by using the IP config all, and destination IP address is the IP address of the UCJ server. And how can we verify? We verified it by using the nslookup command. Even you can use the ping command also. Alright, so version is 4, length is 20 bytes. If you see over here, total length is 461, right? So the length of data or the payload is 461 minus 20 bytes. Fragment offset is 0, and coming to the protocol is TCP. That means TCP is used by the transport layer, because HTTP packets use TCP as the transport layer protocol. So TCP, the number is 6. Alright, now coming to the TCP. So what we have analyzed? We have analyzed physical address, we have analyzed IP address. Now port number and the host number. HTTP, the port number used by HTTP is 80. So if you see source port is the port number used by my system, and destination port is HTTP because I was browsing a website. HTTP always uses the port number 80. Alright, same thing you have over here, flags over here also, which we have already done, but not important over here now. Okay, and port number and the host name. Alright, let's check. Go to the hypertext transfer protocol. Do you see here the host name? Host is ucj.edu.sa. So we have analyzed all the four characteristics which we have to analyze. So this was HTTP get packet. That was a request. Do you see here? Request packet. It's a HTTP get. If you see here, request method is get method. It's a request. Alright. Now let's analyze HTTP response or reply packet. All the fields will be reversed now. Okay. Starting from this. Okay. MAC layer. So the source MAC address is the MAC address for my default gateway. Destination MAC address is the MAC address for my system. IP type remains the same. Network layer, IP. Alright, so the source IP address is the IP address for the www.ucj.edu.sa, that means Jubail University website, and the destination IP address is the IP address of my system. Version is 4, header length is 20 byte, total length is 832. So the length of payload or data is 832 minus 20 bytes. Alright, flags is 0, fragment offset is 0, that means it is not fragmented. Protocol is TCP because HTTP uses TCP protocol. Alright, next we come to the transport layer. Source port is HTTP because this packet is coming from the Jubail University website, and the destination port number is the port number that belongs to my system. Alright, now coming to the HTTP protocol over here. HTTP, if you see over here, it's a request version 1.1 and it's a response packet over here. Now here you have many fields like content length. We are not interested in this. Is HTTP response and how many seconds it took for the HTTP response. Here it says what is the type of the server also. It's an Apache server and many other fields. So you can go through all these fields. Alright, now coming back over here, you can save it, and you can save this capture traffic and you can check it if you want to do it later. So I will finish it over here. In the next video I have one more lab for this week, so I will explain that lab. Thank you so much.